Okay, so now we're going to do the last pages, 6, and then the summary page. So same thing, octet rule, 8 valence electrons, ionic. They're going to transfer electrons. Between a metal and a non-metal. So titanium is Ti, fluorine is F. Titanium is your metal, fluorine's your non-metal. Electron configuration 2-8-10-2. So 2 valence electrons, so they're very much going to want to get rid of those. Fluorine 2-7, 7 valence electrons, so it's very much going to want to gain 1. All right, so ionization energy is our energy to remove an electron. So these should be relatively easy to remove because there's only 2 of them. So 659, they're pretty far away from the nucleus because they're in the 4th ring. So they're also going to be relatively easy to remove. As far as fluorine, we're going to expect it to be really high because there's already 7 and they're only in the 2nd shell. And it's 1,681. So really high to remove one of those electrons because there's already 7. They don't want to remove one. And it's only in the 2nd shell. So these negative electrons are very attracted to the positive nucleus. So imagine our positive nucleus, and then we have our rings of electrons. So these 7 electrons are right here, relatively close. Electronegativity is our attraction for electrons. So if you remember, fluorine is the sexiest element on the whole table, the most attractive. 4.0 is the highest electronegativity. It's the most attractive one on the whole table. Very, very much can gain one of those electrons. And then we would expect titaniums to be relatively low because it doesn't want to attract, it wants to get rid of those. So titanium then would lose its 2 and have a +2 charge. And the fluorine would gain 1 and have a -1 charge. So when we go ahead and do our electron dot, we have titanium with its 2. We have fluorine with 7. So titanium's going to give 1 to fluorine. Then we have another fluorine. Titanium's going to give 1 to that fluorine. So titanium now has lost 2. So titanium with a +2 charge. We have fluorine that had 7 of its own, 1 that it gained. So each fluorine has a -1 charge, and there's 2 of them. So our charge is going to be TiF2, or titanium fluoride. Okay. All right, so the next page is the summary. So in other words, to summarize, our ionic compounds are a transfer of electrons. So one is giving its electron to the other, which is the metal and a nonmetal. The metal is the one that's giving its electrons to the nonmetal. And when we have a metal, that's our positive ion, that's our cation. And then we have our negative ion, which is our anion, anti against negative, cation, positive. Meow, meow. To write the formulas, we can do our very simple crisscross that we learned back a couple topics ago. So if I have calcium with a +2, I have chlorine with a -1, I can just crisscross and do CaCl2. If I have magnesium with a +2 and I have oxygen with a -2, I know that the +2 and the -2 balance each other out. So my formula is MgO. This one wants to lose 2, this one wants to gain 2. If I crisscross, it'd be Mg2O2, and we don't do that, we write in those terms. And then as far as our electron dot, you're going to use an arrow to show transfer of electrons. So in other words, if we looked at the one up there, I've got calcium with the 2, I've got chlorine with the 7. I'm going to use the arrow to show that I'm giving to the chlorine. And I'm going to use an arrow to show that I'm giving an electron to the chlorine. Okay, and 1 dot for each valence electron. And then as far as naming, we don't have any prefixes. So in other words, this would not be calcium dichloride, it's just calcium chloride. And we end with "ide." So we don't say calcium chlorine, we say calcium chloride. Okay, so that should be all of the notes pieces that you have. Hopefully you went through each of the videos and that's in a pretty good place right now. So I'll go ahead and assign you which ones I want you to do on the next couple pages for homework. Okay, thanks guys.